We're going to take a look at the third method here. This method is going to work for every situation. We're going to use a method called completing the square. First of all, I want to show you how to solve quadratic equations by completing the square. Now, for practical purposes of solving quadratics, this is not the way to go. Okay, when you've got a quadratic equation and you want to solve it, you don't and shouldn't automatically think, oh, I think I'll use completing the square. It's a little bit cumbersome, it's a little bit time consuming, but it will be used if you go on and take later math classes, and it'll be assumed that you've seen it before and have got this skill. So that's why we have to make a note on it, because if we didn't do it, it would be a big hole if you go on to take other math classes. Tech Math 2, you will use it in Tech Math 2 when you start doing a little bit of analytic geometry. And the method I'm going to show you will work whether there's no solutions, that is to say they're imaginary, or whether there's one solution, or whether they're both real. It'll work all the time. That's why the quadratic formula, which comes from this, works all the time. So, before we can complete the square, we've got to look at a couple of short equations and see a technique for solving them using the square root property. That's what we're going to do now. We are not completing the square in this example. All we're doing is we're using square roots to solve this equation. We're going to use this technique in a minute. Now, we want to solve that for x, flat out. So you tell me, what's the first thing we're going to have to do here to solve for x? Huh? You could FOIL it. You could FOIL it and turn it into a regular quadratic, but we could shortcut this. We want to get x by itself, so how can we unload that squared sign? Square to both sides. So we can then say that the square root of x minus 7 squared is equal to the square root of 16, and that's the plus or minus the square root of 16. So, of course, this just becomes x minus 7, and that's equal to plus or minus the square root of 16. Well, we know that the square root of 16 is 4. So just by taking the square root of both sides, on the left we get x minus 7, on the right we get plus or minus 4. Everybody agree with that? Well, then we're set. To finish this, we can just add 7. And what we end up with is x equals, we'll put our known value of 7 in the front, 7 plus or minus 4. So apparently, how many solutions are there to this equation? 2. What are they? X equals 7 plus 4, which would be 11, or 7 minus 4, which is 3. There's our two solutions. Now, this is an easy problem to just double check to make sure that both of them work. Go back to your original problem and plug 11 in there. Does this work, or does it hold true? Yeah, sure it does. 11 minus 7 is 4, 16. 3 is our other proposed solution. 3 minus 7 is negative 4. Squared is 16. So yeah, it works. Okay, same basic principle. Let's solve this one for x. What do we need to do first? Bump that 13 to the other side, so we have 16 times x minus 3 halves squared equals 13. We're adding 13 to both sides there. Because we want to get x by itself, so I'm starting to strip away everything to get down to that parentheses. Once I get down to the parentheses, then I can do like in the last example and take the square root of both sides, and then I can solve it for x. Now, if my goal is to get everything stripped away from the parentheses so that I can take the square root, okay, I got rid of the 13, that's over here now. Now what do I got to do? Get rid of the 16, so we're going to divide everything by 16. So now I have x minus 3 halves squared equals 13 over 16. All right. Well, now it looks just like the last example we did. So how do I crack open those parentheses? take the square root of both sides. Square root of the left side is just going to be x minus 3 halves. Square root of the right side is going to be plus or minus the square root of 13 over 16. Exactly. The square root of a fraction is the same as the square root of the numerator over the square root of the denominator. I'm going to write that as a separate step, though it's not necessary. X minus 3 halves equals plus or minus the square root of 13 over the square root of 16. Which is the same as plus or minus the square root of 13 over the square root of 16 is 4. Add those 3 halves. So plus 3 halves, plus 3 halves. And so we got x equals 3 halves plus or minus the square root of 13 over 4. But it'd be nice to have a common denominator here. It's an easy common denominator to get. Let's rewrite that as x equals 6 over 4 plus or minus the square root of 13 over 4. That's right. 6 plus or minus the square root of 13 over 4. And there's our solution. Now we could compute what the square root of 13 was and take that one step further and find the decimal equivalencies, but that's the exact, those are our two exact solutions right there. Put your pencils down for a minute. All right. Just look at that. Will that factor? No, it won't factor. Leave your pencils down. I want you to tell me some number that I could put in there so that it would factor. Any number. I heard a 16, I heard a 15. Both of those would work. Any others? I'm going to list some choices in. Keep your pencils down. I don't want you putting this in your notes. I just want you to think about this. 15 would work. 16 would work. What else? 8. Well, let's 4, 8. Let's try them. Okay. Let's try all 4 of these. First of all, let's try x squared plus 8x. Let's try the top one first. Plus 15. No, you don't have your pencils, do you? Good. Keep them down. X squared plus 8x plus 15. This will factor into x plus 5, x plus 3. True. Okay, so 15 is good. 15 would be okay. What about 16? X squared plus 8x plus 16 equals 0. That'll factor into x plus 4, x plus 4. Now that is of particular interest. That is a good choice right there because it factors into x plus 4 times, it factors into the same binomial. That's the one that we want. But let's go through and factor and see if it'll work for the rest of these. What about x squared plus 8x plus 4? Will that factor? It won't. Okay, it's not going to factor, nor will 8. But the key is that we found the number that will make this into a perfect square, and that was x plus 4 times x plus 4. All right, that's if that would have been a 16. Unfortunately, it wasn't. Now, don't pick your pencils up yet. I got another question for you, okay? Forget this example. We're going to go back and put that back the way it was. Keep that in mind. I'm going to give you another example, and I want you to tell me what number to plug in here. What number goes in here that would turn this one into a perfect square? I hear a 36. Is that true? It is true. 36, and then this would become x plus 6 and x plus 6. Okay, and here's another one. X squared minus 20x plus equals 0. What about this one? What would go in there to make this into a perfect square? That's right. So the question is, how is it that you're finding that number to fill in that space to make it into a perfect square? You do the same thing every time if you spot it. Two equal things that have to add up to that, right? They have to multiply to give you that and add up to that. Well, in other words, what you're doing is you're taking half of that, half of your b term, which in this case is 6, and you square it. So taking half of this is what you're going to put in the back half of each of your binomials, and of course if you multiply them together you get what your missing number is. So here we took half of negative 20, which was negative 10. That's what ended up in the two binomials, but then we got to square it and we get 100. All right? So here's what we're going to do up here. We want to, and this is where the name comes from, we want to complete that square. But we want to have the freedom to choose what number goes in this spot. So the first thing you do is you get rid of it and put it on the other side to open up that space. You can pick up your pencils now. Yes. We want to open up the C position. So all we do is rewrite it. So we have x squared plus 8x plus, we don't know what just yet, equals negative 10. Okay, does everybody agree with that? All we did is slip it off to the other side. We haven't changed the equation. It's still balanced. So now we put in the number in here. Now we put in the number that we want in here that will turn the left side into a perfect square trinomial, or in other words, the square root of two binomials. And what's it going to be? It's going to be plus 16. Now you can do that, but you better do the same thing to both sides. So you better add 16 to the right. So it's worth noting here that b equals 4. And this, excuse me, b is not 4, b is 8. And this position is just 8 divided by 2. We take half of it and square it. And we did that to both sides. Now, you agree with that choice? Okay with that? Now, we're almost done. The left side is really just, if we factor that, that factors into x plus 4 times x plus 4. But as long as we've made the right choice, it'll always be the same factor here, right? That was the idea. So we can really write that as x plus 4 squared. And on the right, we just have 6. So we have x plus 4 squared equals 6. Well, now it looks just like the type of equation we were just solving in the last couple of examples. Let's solve that. What do we want to do to get x by itself now? Square root. So we have x plus 4 equals plus or minus the square root of 6. Everybody agree with that? X plus 4 is plus or minus square root of 6. And if we solve for x, we'll subtract 4 from both sides. And we end up with x equals negative 4 plus or minus the square root of 6. And there's our two solutions to that quadratic equation. Now we could again compute what the decimal equivalents of those are. There will be times when we do that, but for now we're just leaving the exact values. We solved it by completing the square. Okay, let's solve this one by completing the square. X squared equals 7x minus 4. All right. Well, the first thing we have to do is, yep, we're going to leave that constant space open anyway. We want to, we want to leave the constant space available on the left anyway. So let's just leave the negative 4 on the right. And we have x squared minus 7x, we're going to leave some space there, equals negative 4. Now we can choose the value that we want to go in there. So the question is, what goes in that spot? Well, what's your value of b? b is equal to negative 7. And so our c term is going to have to be, what? How do you find it? Negative 7 over 2 squared. And that's what we're going to put up in that space. Well, what is negative 7 over 2 squared? Yeah, the top number will be 49. Bottom will be 4. So we're going to add on 49 over 4 to both sides. Okay. So the left side now is what binomial squared? I'll give you a hint. X. It's no. Minus 7 halves. Because if you take this now and square it, you'll end up with 49 over 4 if we were to FOIL that out. X minus 7 halves squared. Everybody agree with the left side? No? I'll put an extra step. This is a step that I don't want you to get into the habit of doing, but to make it a little bit more clear, this becomes x minus 7 halves times x minus 7 halves. Because when you multiply this out, you're going to get x squared minus 3.5x minus 3.5x. Your O and I combined give you a minus 7x. And your last terms now, negative 7 halves times negative 7 halves, give you positive 49 over 4. So this second term is always just half of the b term. It's always just half of that, or whatever you had before you squared it. Now, what's that equal to over here? Let's add these two together by using a common denominator. Negative 4 plus 49 over 4, that's negative 16 over 4 plus 49 over 4. And that's just changing the common denominator of negative 4. Now, we'll lump those two together in the next step, but it's going to be 33, yeah. So the left side now, we just write as a square. X minus 7 halves squared equals 33 over 4. Okay? Look all right? Well, let's finish it up. Now that we have the parentheses all alone, we can take the square root, and we have x minus 7 halves equals, plus or minus, I'm going to put this as one extra step to make it clear, plus or minus the square root of 33 over 4, which is the same as saying x minus 7 halves equals plus or minus the square root of 33 over the square root of 4, which is 2. Well, remember, if you've got a sign on a fraction, it can go with either the top or the bottom. We always just associate it with the top. And we're 99% done. The last thing we need to do here is add 7 halves. So x equals 7 over 2 plus or minus the square root of 33 over 2, which we put over that common denominator and say 7 plus or minus the square root of 33 over 2, and we're done. We could compute what those decimal values are, but that's exact. And we solved it by completing the square. Now that, of course, is the same thing you would have got if you would have shifted all these terms to the left, labeled them A, B, and C, and plugged them into the quadratic equation. You would have gotten the same result. And so you're asking, well, then why do it this way? You just have to take it on faith. This is a skill that will be useful later. So based on that last example, incidentally, what is it that made this problem uglier than that problem? It's worth noting. What is it that made the first one we did less awkward than doing this one? Anybody spot what the key to this one was? It's an odd number. When your B term is an odd number, then you got to add a fraction in here because you're going to take this and divide it by 2 and it doesn't turn out to be a whole number which we square. Okay? Say that again? Yeah. Yep. Okay, so let's solve this one. What is it about this example that's slightly different than the two we've done before? We have an A term that's not 1, but you know what? That's not going to be a problem. All we do is divide both sides by 5 to wipe out that A term, and then it's gone. So it's no trouble at all. So we have 5x squared minus 30x plus 20 equals 0. Yep, you can't complete the square if your A term isn't 1. Well, you can, but there's no need to. We want to get this A term equal to 1. We'll just take and divide both sides by 5. That takes care of that problem. So what is our new quadratic? This first term becomes x squared. Next term becomes minus 6x. Now you should have a little shiver of joy when we just did that step because what just happened? It's a nice even number. This isn't going to be a bad one to work with. Even ones aren't so bad. Odd ones are a little ugly. Even case. All right, good. Plus 4 equals 0. Okay, well that's just like the cases we've done before. So let's shift that 4 to the other side and get our C position opened up. X squared minus 6x, leave some room, equals negative 4. Okay, well, what are we going to pop in this spot? Plus 9. That's right, everybody see why it's plus 9? Take half of that. Our C term is going to be half of that, negative 6 over 2 squared. So negative 6 over 2 is negative 3 squared is plus 9. We better do that to both sides. Okay, well, we got the 9. Now we know the left side will be a perfect square. So we can then write it as x minus 3. That's right. Take the square root of both sides. X minus 3 is equal to plus or minus 5. Thank you. X minus 3 equals plus or minus the square root of 5. And we'll get x by itself by adding 3. So in this case, as it turns out, x is equal to 3 plus or minus the square root of 5.
Always works too?
And this will always work. Yep, in fact, we just ran out of time, but we were just going to, the next example we would do is a case where you get imaginary solutions. Well, where would they show up? Where would you know? At what point would you be working through this and you'd realize that you were not going to have any real solutions? You wouldn't know it here yet. Here you're saying? That's right, because what would show up right here that would be a tip-off? that would be a negative number. When you complete the square, if this turns out to be a negative number, it's trouble, because look where that 5 ends up. It ends up underneath the square root sign. You'd have square root of a negative number, and then you'd know that you have imaginary solutions.